case, I would suggest we start with the next presentation, which is by Jonathan Bowen about two theories of responsiveness. So Jonathan, I think you can just share your screen whenever you're ready.
Get this camera set up. Okay. All right, how's this? Does everything look functional here? Good to go? All right. Okay, so hello. I'm going to talk about responsiveness. So here's what I'm going to do. I'm going to just introduce what responsiveness is. Then I'm going to describe two theories that have been given to explain what it is. And then I'll say a brief word of evaluation. So the notion of stimulus and response are everywhere in psychology and the life sciences. So here's just a little response eye candy. This is a stentor responding to some irritant. It kind of shrinks back and then it swims away. So stimulus and response are experimental psychology's main independent and dependent variables, respectively. And also, you tend to see something like response to stimuli or responsiveness in list theories of life. So what is a stimulus and what is a response and what is responsiveness? So I claim that there have been two sort of main approaches to this, or two main theories. So I'll just describe them both now. So the first one I'm calling a functional pathway theory. And this is a very old diagram from Descartes. This has been the dominant causal theory of responsiveness since at least Descartes. And so this image is kind of quaint. You know, we'd probably say some different things about what's going on up here in the head now, but at a very high level of abstraction, the underlying picture hasn't changed much, actually. So in particular, you always see recurring in psychological theories three components. So there are always sensors, there are central components, and there are effectors. And those are arranged in a feed-forward kind of fashion. So let's just say something about what each of these components are. So sensors are transducers. They transform energy at a sensory surface of the organism, and then they output to the central component. Let's talk about the effectors next. The effectors transform input from the central component into activity or behavior. And so what can we say about the central component? So it kind of has its work cut out for it. It has to take input from sensors and produce output for effectors and do something in between, some kind of integration. So this is where you might put the task of cognitive psychology, is to say, well, what goes on in the middle? And it's natural to talk about that in terms of information processing. And so people apply this scheme to humans, organisms at large, and of course, it's used in the design of robots. So what do stimulus, response, and responsiveness amount to on this picture? Well, a stimulus is just an application of energy to the sensor. It's pretty straightforward. Response is a little more complicated. So a response is an activity that's produced by the effectors, where that activity is the culmination of activity that began with a stimulus. So it has to pass through the whole sort of causal pathway to count as a response. Now, finally, an organism or a machine is responsive when at least some of its activities are responses defined in that sense. Okay, so now to the second theory. I'm going to spend a little longer on this because it's a little bit less familiar. But this theory, I wouldn't say it was ever put together in the same place, but I'm drawing it from a bunch of loosely allied approaches in philosophy and in psychology and in biology. I've listed some of the sort of sources here. So the American pragmatist philosophers, the functional psychologists, people who call themselves organicists, and some humanistic psychologists. So all of these people have in common that responsiveness is something that specifically organisms do, and they do it as a whole and it manifests in their conditions of living. And its deeper roots, you could say, are with Aristotle and Darwin. And that might sound, you normally don't put those two together, but I'll explain how that works. So let's start with Darwin's theory of natural selection. So this is how, this is how species originate. And for it to get going, you need a population of organisms that are surviving and that vary and that reproduce and pass on their traits. So what can we say in general about these organisms, the population that's being, operated on, or that's evolving? Well, most theories that try to say something about what an organism is in general have this notion of metabolism. And it's hard to escape this kind of idea because organisms, they're complex, and that's kind of confusing because complex things tend to fall apart, but organisms, they grow. And if they're injured, they repair themselves. And that's kind of weird. So they do that by basically taking in sources of energy and assimilating them to themselves, and then sort of getting rid of the waste products of that. So here are just two common kind of ideas about minimal models of life. Here's Ganti's chemoton. So you see this circle here, that's the metabolic process. And here is a very simple diagram of an autopoietic machine, which is basically continuously creating itself. And that too involves a kind of metabolism. But if you look at both of these diagrams, you see that they sort of have requirements. They have these arrows going in. And now I'm going to say something that'll sound very obvious, but it's very theoretically important, and that's this. Organisms have needs. So if an organism has a metabolism, that implies that it has a need. So a need is just a set of objective conditions that are required to sustain the organism's vital processes. So I'm using the word vital here because both of its senses work. It's vital meaning pertaining to life, pertaining to these metabolic processes that constitute living things. But it's also vital in that it's necessary. If the process is stopped, the organism dies. That constitutes not surviving. So if living is constituted by these vital processes, survival amounts to reliably meeting your needs in a certain kind of environment, despite obstacles and threats. So interestingly, just from those premises, you kind of get a ballooning set of needs because there are as many needs as there are ways to thwart these vital processes. So for instance, does the organism have a metabolism? Yes. Then it has physiological needs. Is the organism vulnerable to environmental threats? Yes. Well, then it has safety needs. There are conditions that are safe and there are conditions that are dangerous. Does it depend on a social form of life? Is this some kind of social organism, like a bee or an ant or something? Well, then it has social needs. It needs to be integrated into the community that it depends on to continue living. So survival consists in meeting needs, and evolution is going to select for organisms whose activity accomplishes this. So what does that look like? How do you diagram that? Well, here, to answer that question, you have to ask something about the overall behavior pattern of the organism. So what does the overall behavior pattern of an organism whose needs are reliably satisfied look like? Well, it looks like a kind of integration with all of the need satisfying conditions for that organism. So here I've got, so this little green circle, that's our organism. You've got food over here, it's got a kind of relationship with that. You've got a house, so that's shelter. You could think of that as providing some kind of safety needs. Of course, not all organisms have houses, but you get that I'm trying to depict something more abstract here. And then you've got, the other organisms. So here's a conspecific, and here's its community. Our organism is integrated into its community. So the whole pattern of life, you're going to see this organism going between various places, doing various things, all in ways that reliably lead to its needs being met. But these functional relationships, they don't come from free. They have to be established. They take time to establish. It's a developmental process to establish them, and you have to reestablish them when they break. So this is where responsiveness comes in on this picture. So here is a great term, read integration or read integration. So here's just a little dictionary definition. It's to restore to a state of wholeness, completeness, or unity. So this notion is used by Dewey when he's describing what stimulus and response really amount to. And stimulus and response on this picture are sort of phases of this process of basically forming an integration with something that an organism has not yet formed an integration with. So it tends to proceed in 4 phases or steps. So here's our organism with its sort of settled way of life. So let's just draw a little happy face there to kind of depict that. Well, then there's some kind of disturbance. Something happens, something changes in the organism's environment, a threat emerges, or an opportunity appears, or something that has been relied upon changes. Well, then the organism enters what Dewey calls the first phase of tensional activity. So the organism is not going to be doing the same things it was doing before it came into contact with this change, which it needs to integrate its activities with respect to. And so the state that the organism is put in, we would expect to see converge on being something apt to the kind of adaptation that needs to be formed to the threat or to the opportunity or to the change. So after that, you get something Dewey calls organismic search and exploration. So here, the whole organism's activity is kind of reconfigured so as to be selectively exploratory and to locate some relevant need satisfier or means of using and enjoying that need satisfier. So here, if he's found a dagger or something to protect him against this tiger. So now this final phase tends to be called consummatory activity. So this is either eating the food when you're hungry, neutralizing a threat, like in this case, I suppose, or maybe completing a job interview if the need is a social need for employment. So at the end of this process, the organism's enlarged its integration with its environment, and that includes altering its habits and the habitat that it's in. So what is a stimulus and a response on this view? Well, a stimulus is basically corresponds to the second step, this entering into this tensional state where the behavior changes of the organism. And a response is basically steps 3 and 4. It's the organismic search and exploration, and then the sort of consummatory activity, which restores integration with this new disturbance. So an organism is responsive on this view if it has a tendency to undergo this whole process of read integration. Now, I don't know if I have time for this, but so just to sum up, here are some differences between these two views. So the functional pathway theory of responsiveness takes it that responsiveness is about implementing a certain kind of abstract architecture. The vital integrative theory, on the other hand, really focuses on the relationships between the organism and its environment insofar as they meet its needs. Now, how do we understand the causal basis of responsiveness on these two views? Or how much do we understand it? Well, on the functional pathway theory, we sort of feel like we understand it in theory. But on the vital integrative theory, there's a lot of work to be done here. What is the causal basis for something which can build up these integrations with its environment? So there's a lot of good work to be done there. For the explanatory style of these two things, of these two theories, the functional pathway theory is clearly mechanistic, whereas the vital integrative theory because it's always talking about the organism as a whole and its pattern of life activity as a whole, it's kind of a holistic approach, maybe an organicist approach. And finally, one more important point is that on the functional pathway theory, the causal processes are in the organism, whereas in the vital integrative theory, they sort of span the organism and its environments insofar as they are relied on for the life processes. So in conclusion, it's clear that this functional pathway theory has been more or less completely dominant in the cognitive sciences and in the life sciences, unless there's something I'm not thinking of. And on the other hand, this vital integrative theory, it's kind of been put aside. It kind of fell out of favor in the mid-20th century. It had a little bit of a heyday before then. But I think it has a lot of things to teach us with its focus on how the organism kind of, on its relationships with other things that it relies on. So I think there are a lot of resources to be recovered in these traditions, and hopefully it's of use. So thank you. I hope that was stimulating. And if you want to respond, now is your time.
Great, thank you, Jonathan. So it's a really interesting talk. There's a question from Vincent in the chat. Are there new predictions about organism behavior, evolution, etc., that this new theory makes that the old theory does not?
Good question. Off the top of my head, if you were to remove something that this organism relies on to meet its needs, you would see a kind of compensatory adjustment. You would see it find something else to fill the role, and you would see it establish that role. So for instance, if I woke up this morning and my fridge was gone, you know, I have to find a new food source. I'd probably have to order Uber Eats or something as I get my fridge installed. But so here, you can make that prediction about my behavior before I've come into any kind of contact with the fridge. So that's one sort of class of predictions you could make off the top of my head. I think that works. I see a follow-up.
Yeah.
So should I take that or?
Please.
Okay. So can I interpret this as a stimulus, hunger, and response, behavior? Well, so we're trying to decide what stimulus and response amount to. If we're talking about this vital integrative theory, the stimulus would be it would be me entering this state of hunger, I suppose. I'm not sure if this is the best example, but the stimulus is when some change some change in the environment occurs and the organism enters into some kind of tensional or motivational state. So it's an intrinsically motivational theory. The stimulus is the formation of that initial motivation. The response is whatever you do to resolve that motivational state.
There's another question by Sharon Minsuk. It seems odd to ask which of these theories is better. That's like asking whether it's better to describe the operation of a car in terms of the engine and the gasoline and the drivetrain, or in terms of the driver and their needs to get to a destination. The two theories serve different purposes and neither is better.
Yeah, I'm going to agree with you. That's probably was not the best way to compare and contrast these views, or the best way for me to frame it. One interesting question worth asking is whether these theories are compatible or whether they're not. In the two cases you contrast, clearly it's compatible with the same vision of reality that gasoline, or the role that gasoline and drivetrain plays in the engine, and the fact that a person drives the vehicle and where the vehicle is depends on where the person wants to go. So those are clearly compatible. Do these two schemes give us incompatible views of the organism and of the patterns that constitute stimulus and response? They might. They might. These might be conflicting theories. But more work needs to be done to clarify that. I plan to explore that.
So to pick up on this line of questions, I wondered whether your vital response theory just refines or needs a refinement of the central processing units of the mechanistic theory, so that in order to be responsive, they cannot just be a black box, but at least a black box that has a certain behavior or meets certain requirements.
Yeah, so that's a good question. One thing that's sort of interesting is that on the second view, it's a lot more open to understanding the actual mechanisms of the organism as depending on outer objects. So they sort of pivot on things outside of themselves, and that's how they work. And a lot of these kinds of integrative, regulative control sort of processes, maybe they can be distributed throughout. First of all, they involve the whole organism. So, I mean, if we think about an activity like chasing, I'm not sure that's actually a good example. So the thing about, so the central component is a component mechanism in like a sort of input-output system, right? It's describing how some part of the organism is contributing to its whole pattern of activity. And so just to clarify, was the question whether the vital integrative theory could just incorporate the notion of a central component, like does it, or does it require it? Was that the question?
Or whether it refines the mechanistic theory by adding requirements to the central processing unit, like being able to be in different states of alertness or readiness.
Right. Okay. Yeah. So can you account for these bigger patterns of, you know, entering into a motivational state and then doing things like altering your activity and searching for certain sorts of need satisfier? Is that something that you could give a theory in terms of the central component to account for? And yeah, I think you could try to. I think you would probably want to use notions of representation, representing the problem, representing certain value states, etc. And I think that probably is a very familiar approach to solving ecological problems of that kind, is to think about how can you represent the problem and how can you, represent the mechanism that instantiates it, or maybe a program that instantiates it. So that's that is one approach. You could take the patterns that that the vital integrative theory describes and try to explain them using a mechanism like that. Could do that, and most people have been doing that, I think.
So your talk actually stimulated the audience a lot and led to a lot of responses, which are in the chat, and we couldn't address all of them. Maybe you all bring this discussion later into the Slack channel. Yeah,
totally. Yes.